Yeah, so this protocol OSPF, Open Shortest Path First, we saw various important points, like this is a link state routing protocol. This uses administrative distance as 110. In Cisco, the given administrative distance for OSPF is 110. That's the preference level, that's the important level to this protocol. So if you take Cisco router, the Cisco's protocol has got more importance than OSPF. What's the administrative distance of EIGRP?
90.
Smaller the number, more importance. Though it is more important in Cisco, but widely used protocol is OSPF. It is the OSPF, not EIGRP. So Cisco might have given more importance to the protocol by giving small number. Again, they have given an option for you to change it, but truth is OSPF is more popular. OSPF is more popular than EIGRP. You can say the most popular protocol, routing protocol, IGP protocol, is OSPF. Administrative distance is 110. So you cannot judge by looking into the administrative distance. Administrative distance is a configurable number. The default for OSPF is 110. Another thing that we learned is OSPF advertises the link status, not the routing table. That helps the routers to learn the complete topology, at least within an area. Within an area, the LSDB will be unique within an area. Don't expect identical LSDB across the autonomous system. No. What is an autonomous system here in OSPF? Having one area 0 and other areas connecting to area 0 together, all called as one autonomous system. Throughout the autonomous system, definitely the topology table is not going to be similar, but within an area you will always have the topology table, which is called as OSPF database, similar. And the algorithm that is used to find the best path is shortest path first algorithm, SPF, which is also called as Dijkstra's algorithm. Based on the Dijkstra's proposal, this routing protocol is now working. Dijkstra did not design this routing protocol. It's based on that algorithm this routing protocol is designed. So OSPF is an RFC. It is not Dijkstra's protocol. Dijkstra's algorithm, SPF, shortest path first, is used here. Next thing what we learned is different type of tables that we have. 3 tables. Neighbor table, which will have the established neighbors. Topology table, which will have the identical map within an area. Routing table that has got best routes in the routing table. Next, why link state routing protocol? You see, the last point is what is very important. Accurate decision. Because this routing protocol can provide you a full picture of the topology in each area, you will have full picture in each area. When a route is down, they can take a fine-tuned decision. They can immediately take a decision to forward the packet using alternate path, the other path immediately, because they don't need to query or wait for response. So fast converging protocol is OSPF. To provide high scalability, we don't put all the routers and thousands of networks in one group. We group them into small groups called area. and all this area will be connected to one backbone area called area 0. Area number 0, no, the number 0 is reserved only for backbone. You cannot make area 5 as a backbone. And you cannot make area 0 as a non-backbone. It is always area 0, reserved number in OSPF. But that is not the case with ISIS. Yeah. So, two levels of hierarchy consist of following, like area 0, which is also called as transit area. You know why this area is called as transit area? The reason is, if a traffic wants to go from this router X which is in area 10. Now this is area 10 is connected to backbone area. Definitely it cannot connect to area 11. So now area 11 is connected here. This is what? This is area 0 always. And now area 11 router has got a computer here which is Y. Now area 11 Y and area 10 X wants to communicate. The packet needs to go through is the clue, through transit. It has to go through area 0 in order to communicate. Even if you have direct connection like this, even if you have a wire like this, the packet won't go this way. Why? Area 10 routes will never be advertised through this link. Area 10 routes will go to area 11 only by area 0. That's the rule of OSPF. This cannot even form neighbor in first place. Why? To form neighbor, the area ID should match. This will say I belong to area 11. This will say I belong to area, this will say I belong to area 10. This will say I belong to area 11. They cannot form neighbor. So no route sharing happens through this link. No routes will be pointing towards this path for X or Y. It will always be via area 0. That is why it is called as transit. Transit is not a source nor a destination, but it is simply used. When you go to various countries, faraway countries, sometimes you may be going through a transit. What does that mean? Intermediate. For example, those who go to Sweden from India, Bangalore, you need to go via Delhi. You will land in Delhi. Delhi is a transit. Or sometime you will go to Oman, from Bangalore to Oman, from Oman to Amsterdam. Oman is not your source. Oman is not your source nor destination. Likewise, Amsterdam is not your source or destination. Your destination is Sweden. Yeah. So all these in the middle stoppings are called as transit. This is the word transit. So area 0 is always a transit area for other area traffics. Regular areas are the one which may be a source nor a destination, source or destination, a regular area. Transit area, regular area. Two levels of hierarchy, transit area, regular area. Now, what is the advantage of having area? This also we saw in the previous class. We get a summarization point. C, D, and E are the summarization point. You cannot summarize on F or G or H or A or B. No, OSPF never allows you to do summarization. You can do summarization only on ABR. Why this is called as ABR? One link is connected in area 0, the other link is connected in area 3 or 2 or 1. So those areas that are in the border, those routers that belong to area 0 as well as a regular area, those routers that belong to transit and regular, backbone and non-backbone, those routers that are in the borders are called as area border router, ABR router. ABR router is the place where we do summarization. Remember this till I finish this OSPF at least, because you need this knowledge even on the last topic of OSPF. The summarization point is only ABR, area border router. C, D and E are the summarization point in this topology. We cannot, not at all, we cannot do summarization on A, B, F, G and H. Not possible. Right. Why are we doing summarization? Why do we need to do summarization? To minimize the routing table entries. Do you agree? If you summarize and send, the other area's routing table will become a minimized one. Without summarization, when you send, the routing table is going to be too big. More buffer, more processor consumed. Not only that, if you don't summarize and send, if any change happens in an area, if any change happens, let's say there's a network going down here, that will be impacting every router because you have not summarized. But when you do summarization, the changes will be localized. The impact of the change will be local. Next, the detailed LSA flooding stops at the area boundary. Detailed LSA flooding stops at the area boundary. That's what I said. When you do summarization, the detailed LSA will not go. Even if you don't do summarization, no, I don't want to complete this statement because it's going to be wrong. So, only when you do summarization, this is possible. Detailed LSA flooding stops at the area border router. So, you see, summarization is so important. But if you want to do summarization, you need area. Without area border, can you do summarization? Not possible. That's why we need area. If you don't do summarization, the LSAs are going to be detailed, and when small route goes down, then it is going to impact the entire topology. All will be running the OSPF process as per the new change. That's not good. See, for these three advantages, we need to do summarization. But to do summarization, ABR is mandatory. To have ABR, areas are mandatory. So this is the reason why we have areas. This is how areas can solve the problem of flooding the detailed LSAs to every area, impacting all areas. Big routing table. So can be solved only with the help of areas and ABR and summarization. When you do these things, when you have areas and when you do summarization on ABR, the minimizing routing table is possible. Localizing the impact of topology change can be achieved. What does it mean? If any change happens in an area, it won't impact the other areas. Instead of sending a detailed LSA, we just send a summary LSA. That will definitely improve the scalability, the efficiency of OSPF network. Yep. As I already said, C, D and E are the ABR. A and B are backbone routers. F, G and H are internal routers. Now we also learned that OSPF sends hello packet like EIGRP. Can someone say how often EIGRP sends hello?
5 seconds.
5 seconds. Every 5 seconds. Every 5 seconds EIGRP sends hello, and 15 seconds is the dead timer. For OSPF it is 10 seconds. OSPF hellos are sent every 10 seconds. And if a neighbor is not sending hello for 40 seconds, the neighbor is considered as dead. 10 and 40. 10 and 40. This is OSPF hello timers. But this is not the only timer we have in OSPF. Later on, when I teach you WAN concepts in OSPF, I'll show OSPF sends hello packet every 30 seconds. And that is after 4 times. But this is not a usual one, unusual in a non-broadcast environment. We'll talk about that later. So, hello packets are sent every 10 seconds in a LAN environment. So let's focus only on the LAN. Hello packets are important to form a neighbor. To form neighborship, hello packets are important. Without hello packet, they don't discover each other. If no discovery, no exchange of route. So very initial building block for adjacency, OSPF adjacency, is the hello packets. So router discovers neighbor by exchanging hello packets. Hello. Right, most of the people, not, I'll not say everyone, most of the people begins their conversation by hello. In telephone or in face-to-face meet, begins with hello, mostly. Very rarely I have seen someone just coming and talking to me without saying hello. Very rare. Yeah. At least, some sort of hello they say. In some countries instead of hello, they use how far. How far. That's how they begin. How far. And then they talk to us. But some sort of hello is always sent. Router discovers neighbor by exchanging hello packets. Routers declare neighbor to be up after checking certain parameters and the options in the hello packet. See, if two routers wants to form neighbor, they need to send hello. But the hello will not guarantee the neighborship. If someone says hello politely, you form neighbor. If someone says hello, will you form neighbor with them? No, he's in a threatening voice. He says hello in a threatening voice. He means something else. He wants to say, hey, I'm here. Something like that. So, parameters in the hello is important. For some, they expect the respect in hello. When you say hello, the voice, the pitch, the pitch is important. Likewise, for hello to form neighbor, for router to form neighbor, the hello should have few things to match with local router. if D is, let's say, area 0, B is area 1, then the parameter won't match. The area ID is one of the parameter that should match for forming adjacency. Yep. As I said, if an African goes to an India village, he cannot form neighbor. He cannot form neighbor because Indian village people may not know English, but they know the meaning of hello. Everyone says hello. Hello. I have seen some village people saying hello in the phone, over the phone. So what I'm coming to say is they know the meaning of hello and they understand, okay, he's trying to form neighbor with me. But if an African goes there, Hafa, what is he saying? Hafa. What? So he just ignores and go. Indian village people ignores African because they are not saying hello, they say Hafa. The parameter doesn't match. Likewise, for B and D to form neighbor, area ID must match on both sides. Not only area ID, timers should match. Not only the timer, the subnets in which they are must match. Plus there are some more optional things if enabled need to match, like stub. Only after checking those parameters, the neighborship is going to happen between the routers. Now, this is where we need to actually focus more, because I remember up to this slide I explained in the previous class. Forming OSPF adjacency in a point-to-point relation, neighbor. Listen, what is point-to-point? If you have a router connected back-to-back with a serial wire, this is how we draw a serial wire. Serial wire you should draw like this. The Ethernet wire you may draw like this. This is what called as cross cable. Usually between the routers we go with cross cable. So if you are running, this is enough. So this is what point to point. In a point to point, how the adjacency is formed, it is full adjacency. What is full adjacency? Sharing everything that they got. Between these two routers, it will be full adjacency. Meaning, this router 1 will share everything to 2. Router 1 and 2 shares everything. 1 and 2 have got full adjacency. They are not just neighbor, they are also neighbors with full understanding. That's the meaning, full adjacency. But in a LAN environment, serial wires are called as WAN links. So that is WAN environment. In a LAN environment, you see you are connected through Ethernet. You may be connected to 2 devices or many devices through a switch. You have Ethernet switches, right? For serial, you don't have any switch like that. You may have many devices or just 2 devices. So in a LAN environment, this is what called as LAN environment. All these will be in same subnet. So there will be one designated router, DR, one backup designated router, BDR, other routers. And other routers. With only DR and BDR, you will see all forming full adjacency. So, what I am coming to say is, to this router, They have full adjacency, meaning they share everything. I know him, I know her, I know this, I know that, I know everything. They share. But between these two routers, they simply form adjacency, meaning they don't share anything, but they know each other as neighbor. They know each other as a neighbor. He is my neighbor, I know his neighbor, but I don't know what he's doing, where he's working, no idea. Likewise, he don't know where I work, what I do, nothing. But we both live in same street. That is what called as two-way state. Two-way state. So with all other routers, designated other routers, these are all called as designated other routers. There will be only one DR and one BDR in a LAN. In a LAN, there will be only one DR and one BDR. We'll talk more about this DR BDR later. But one thing you should know is one LAN means when we have Ethernet connection, there will be definitely one DR and one BDR. Between DR and DR others, between BDR and DR others, there will be full relationship. But between two DRs others, between two DR others, who is DR others? All those routers that are other than designated router and backup designated router, DR and BDR. They are called as DR others. Routers maintain two-way state with the other routers. Only two-way relationship. Okay, next. More about this will come later. If you understand, happy. If not, don't worry. We'll see this in detail later. Next. Routing updates and topology informations are passed only with the adjacent routers. What does it mean? Routing updates and topology informations are passed only to those routers where full adjacency is formed, not to the one which is two-way state. So route updates and topology informations are sent only to DR and BDR, because to DR and BDR only we have full adjacency. Yeah. So once an adjacency is formed, LSDBs are synchronized by exchanging LSAs. That's very important. Adjacency need to be formed. Full adjacency is formed, then LSDB will be shared. If it is only two-way adjacency, no LSDBs are going to be shared. Detail is coming later. So LSAs are flooded reliably throughout the area. I said within an area you will have a redundant database. Because within an area you will have LSAs flooded everywhere to all the routers. But between the area you will not see all LSAs going to everyone. More detail will come later, but keep looking for these things in detail in coming classes. Now this is about how OSPF finds the best path for every destinations using the shortest path first algorithm, which is also called as Dijkstra's algorithm. I told you every router in the area will have an identical link state database. And I explained the story already. This is not a new story. We are all in a city, but different corner of a city. We are all given with the map. Say for example, this is the city's map. We all have this map. And one of you is in this corner of the city. Another person is in this corner of the city. Another person of you is in this corner of the city. Another person is in this corner of the city. You are in different corner in different hotel. And you want to visit this place. This is the destination. All these routers, see there are 4 routers, they all have identical map. They all want to reach this destination. What they do is, they find their shortest path. So one may take this path, 2 may come via this path, 3 may come via this path, 4 may come via this path. If one will take the path of 2, it will be a long distance. One have to find its own path. See, but EIGRP or other protocols are not like that. Other protocols are, they receive routing table from the neighbor. So, OSPF is the best protocol. So what happens is, in the map, the router will position itself. Router 1 will not position here. Router 1 will say, I'm here, now what is the best path to go to this destination? That's what here it means. Every router in an area has an identical link state database. Each router in an area will place itself, position itself in the root of the tree that is built. This is the tree that is built to reach this destination. It will fix itself, and the best path is calculated using the calculated with respect to the low cost path. OSPF uses metric as what? Cost. This cost is dynamically calculated by the algorithm based on the bandwidth. More the bandwidth, less the cost. More the bandwidth, less the cost. When will be the cost high? When the bandwidth is low. When the bandwidth is low, cost is going to be high. Opposite, no? So the best path is calculated with respect to the lowest total cost of the link to the specific destination. So to reach every destination, which path has got the lowest total cost? There may be many path, many link. What is the total cost via, say for example, if I'm going from here to Paris, what is the total cost if I go via Dubai? What is the total cost if I go via Addis Ababa? Addis Ababa is in Ethiopia. What is the total cost if I go via Delhi? And I choose the one which is low. For some, cost may be the money. For some, the cost may be the time taken. Yeah. Right, so the best path is calculated with respect to the lowest total cost of the link to specific destination. The best routes are put into the forwarding table. So in the routing table, we will have only the best routes. This is how OSPF calculates the cost. The same thing what I have explained now in this page is also explained in the next page with a picture like this. Let's say if I want to go to F destination, assuming each link cost is 10. Each link, what is the cost? 10, 10, 10, 10, 10, 10. Each link cost is 10. So to reach F, if I take this path, it is 10 plus 10, 20. But if I take this path, it is 10 plus 10 plus 10, 30. So which path I'll take? I'll go from F to D to X, or X to D to F. So these dotted lines are not best. This is how the path is calculated. The low cost path is calculated. Now this is an interesting page. You see, from a router, Some advertisements are coming in. LSA, LSU, both are same here. Advertisements, updates. U means update, E means advertisement. An update is coming. If it is single update, we call it as advertisement. Collection of LSAs inside the envelope put together called LSU, link state update. LSA, LSU. Now it comes when it is received on the router will first check, do I have a database with some entries? No, this is the first update I'm getting. Then what does it mean? I need to simply take it and add it to my database. Whatever comes in, I add it to my database. Send an acknowledgement. Thank you for the update. I received your update. Take care. Thank you. Bye. After that, I also flood it to all the rest of the neighbor and then calculate the best path as we saw in the previous page and put the best path in the routing table. Is this part clear for you? This part which I explained to you now, is it clear?
Yes.
Alright. Now next. The link state database is not empty, which means it has got something already. When it is empty, whatever it comes, I add it. But if it is not empty, which means it has got something. But that something may be the one which you already, the something that which you already have may be the same thing which is coming now. If it is same thing, you need to ignore. How do you know whether it is same thing or different update? Sequence number. When a router sends an update, it will put a sequence number. Now if it sends a new update, it will increment the sequence number and send. So what happens is, if I already have an update, if the sequence number is same, what I have and what is coming in, which means it's the same update, I should not learn again. I ignore. If it is different sequence number, I check whether it is higher. If it is higher, means new update, I need to go to A. The A is here. A is here. I need to go here. Add it to my database, send an acknowledgement, flood it to the rest of the neighbor, run the SPF, end the process. But if it is not higher, incoming is not higher. What does that mean? It is lower. Incoming is lower, which means the one who is sending you is sending the old update, not the latest one. You have the latest one. So what you need to do, if you are receiving a LSA with lower sequence number, then you need to send the latest one to the one who sent the lower sequence number update. You need to tell, hey friend, what you sent is the old one. I got something new. Take this in your information. And then end the process. Are you clear with this side? Is everyone clear with this side?
Yes.
All right. Now, in this chapter, what we have seen and what we are going to see is, we have seen some very good fundamentals of OSPF. But there are a few more things which is not explained in the pages, explained here in the summary. This 30-minute. See, we say RIP is sending periodically update every 30 seconds. RIP is not that good protocol, not that scalable, because it sends update every 30 seconds and so on. See, OSPF also sends periodic update. See, OSPF sends hello packets every 10 seconds and updates whenever change happens. On top of those things, OSPF will also send periodic updates every 30 minutes, not seconds. Every half an hour. Link-state routing protocol respond quickly to change, send triggered update with when a change occurs. Not only that, every 30 seconds it sends the periodic update, meaning it will send everything to everyone just to make sure everyone is in same phase, same synchronized table, with same synchronized table. So this is something very important that you should know. Every 30 minutes, OSPF will send a periodic update. Next, we spoke about the two-tier architecture, which is very important for us to do summarization, to reduce the number of updates, to reduce the impact of the topology change, to minimize the size of the routing table. We also learned that the hello packets are sent every 10 seconds and certain parameters are checked. If it matches, it forms adjacency. Adjacency in a LAN, there will be a DR BDR. So full adjacency will be only with DR and BDR. In a WAN environment, there is no DR BDR, so there will be full adjacency. Right, and then we spoke about how the calculation, the shortest path first calculation happens. We also learned how the database is updated when a new LSA comes. It is based on the sequence number. If the sequence number is higher, incoming sequence number is higher, then I need to update my database. If the incoming sequence number is lower, which means I am already updated, the sender is not updated, so I have to update the sender. Right? So it's the sequence number that makes the difference.
So the sequence numbers are in the hello package?
Yes. No, sequence number is not for the hello packets. Sequence number is for the update packets, advertisements, not for the hello packets.
Okay.
So